We will now be working on the camera. Previously I created an item for the camera controller, but we're not really going to use this at the moment, so I can delete this. For the moment we only need the input. I'll be creating a system script to control the camera, so I'll need a new C# script. This script will be called sys player camera. We can now edit the script. Like with the input, this will inherit from system base, and this is because we are inheriting from a mono behavior. Currently there's no dot-specific implementation of a camera, so we will be referencing a mono behavior camera. I will start by referencing quite a few mono behaviors. This will cut down on performance, but it will allow us to get our systems up and running quickly, and we can worry about more performant and customized options later. We'll need to convert this into a public partial class. We'll also want to specify when this is going to be updated. We'll do this before the declaration of our class. We'll have two square braces. Here we'll specify update and group, and we'll specify our group with type of, and we'll update this as part of the late simulation system group. These groups are divisions of how simulations are run within the frame. There are groups of commands which are run together, and most of these are run by default. The late simulation is the last of these groups, which means the camera will be updated after we've updated the majority of the items within our scene. I'll need to implement the abstract class. In this case, this will include the onUpdate method. I can return to Unity and our scripts will update. I'm going to open a window here so we can look at the system groups. This will be under the Windows drop-down, under the Entities drop-down, and it'll be called the Systems window. This will show all the systems which are currently being run in our game. So initially our game will run the initialization. There will then be a sequence of systems which will be run under the initialization. This will be followed by the update. The update will start with a simulation system group. There will then be a fixed step simulation group and a variable step simulation group. These will be followed by a simulation group for the transforms. And then there will be the late simulation group. If we open the late simulation group, we should see that our player camera system is being run here. This means that we'll be updating the camera after we do the majority of the updates in the scene. This will mean that the camera is always updated after the player is updated. If we do not maintain an order between the camera and the player, this could lead to uneven and juddery movement for either the player or the camera. If we take a look at the transform system group, we'll see that we have the system for our player input being updated here. So our system is running, but it's not doing anything, and what we'll want to do with this system is get a reference to the camera. I'll store this in a variable camera, so this will be var camera. We do not, however, have a way to reference our camera, so I'll comment out this line for the moment, and I'm going to create a script specifically for referencing our camera. I'll call this script mono camera. I'll place this script on my main camera. Once the script is assigned, I'll edit it. Here I'll create a public, static, Unity engine, camera, and this will be stored in the variable camera. We'll then perform actions on this on awake, which will be part of the mono behavior game loop. So we'll have the method public void awake. Under standard mono behaviors, awake is the first thing that Unity will execute. Here I'll set my camera variable. We'll set this with get component. This will be a component of type camera, which means we're getting the camera component of this game object. I can now return to my system, and I'll get my camera with monocamera.camera. In this case, I'll actually be getting the transform for the camera, so this will actually be monocamera.camera.transform. We can then test if this is working by updating the position of the camera. This will be done with camera.position. We'll use a vector to set this, so this will be new vector 3. The x-axis will be camera.position.x. So we'll use the current camera's position, and I'll add time.delta time here. The y value will be set by the camera's position in y, and the z value will be set by the camera's position in z. This should cause the camera to move in the x-axis. Time.delta time is also not a value I should use here. That's from mono behaviors. This is a system, so I should actually use system API.time.delta time. I can now return to Unity. We can play, and we'll see our capsule slowly move out of the viewport. We're now accessing our camera and we're updating values on the camera. This gives us what we need to work with, but what we really want is for this camera to move relative to the player and for us to transform the camera around the player's position. So next we're going to add movement controls for the player, and after that we can start moving the camera.